forces are balanced. You continue to fall towards the ground, but you're not accelerating anymore. Okay, and then gravity is the force of attraction between any and all objects that have mass. Anything that has mass is between two things is gravity. It's attraction. Between you and the desk, you and your chair, any two things that have mass will create some form of gravity.
Long ago, a scientist named Isaac Newton wondered what kept together the Earth and the Moon, the planets and the Sun. He thought there must be an attraction between them, much like...
Go back and start that over.
Long ago, a scientist named Isaac Newton wondered what kept together the Earth and the Moon, the planets and the Sun. He thought there must be an attraction between them, much like the attraction of gravity between objects in the Earth. Could it be that everything in the universe is attracted to everything else? Other scientists wanted to test this idea by measuring the attraction between two objects. But this was hard to do, because the attraction of gravity is very weak compared to the attraction of magnets or static electricity. That's why we usually only notice it when one of the objects is very big, like the Earth or the Sun. The first experiment that was invented used very large weights in a very quiet place. But we will demonstrate what would happen if you could do it yourself. At the end of a glass thread, which is very long and thin, we hang a bar. On each end of the bar, we put a lead ball. The two balls balance and the bar is free to turn. Now we put another ball on the left side of each of the two original ones. If everything attracts everything else, the balls should attract each other and the bar should move.
Isn't that cool? So that shows you the force of attraction between two objects. So attraction between two objects is called gravity. Gravity is stronger when the objects with mass are close together. You can see this box falling from space as it gets closer to Earth. Look at its weight as it gets closer to Earth. Its weight is 2,500 kilometers above the Earth. Okay? And it's 88, 200, and 800 newtons. Look how it increases. Look, its mass stays the same. Mass remains the same. Weight is increasing. Gravitational pull is stronger when the objects are closer together. So large mass closer together makes gravity stronger. Gravity is also stronger between objects, obviously, with more mass. Okay? So it should be gravity is also stronger between objects with greater mass. So between the moon and the Earth, gravity is extremely strong. That's why the moon has gravitational pull on the Earth. Gravity attracts objects towards Earth. It keeps planets and moons in their orbits and causes the force known as weight. Okay, well, I hope you enjoyed that video on Felix Baumgartner and him jumping from the edge of space. I don't think I could do it, but good for him. Anyway, objects in free fall accelerate downward at 9.8 meters per second squared. When objects fall in Earth's atmosphere, air resistance is going to increase as the falling object accelerates towards Earth, until finally the upward friction force of the air resistance coming up will equal the downward weight force. I'll give you a second to write this down. Okay, think about the cat falling out the window. Okay, when the cat falls out the window, let's say 11-story window. It spreads itself out. It tries to build up enough surface area so that it can increase its air resistance. When the air resistance equals the downward pull, the downward force, the weight force, it is reaching something called terminal velocity. The object, when those two are equal, will fall at a constant velocity known as terminal velocity. Now I have a little video to show you on this as well. You have to watch the video.
Something's coming, isn't it?
Come, Daddy.
Dark Skies, rated PG-13.
Gravity is a force that likes to pull everything down to Earth at 9.8 meters per second, which means that if you were falling out of an airplane, you'd end up going 9.8 meters per second faster every second that you're in the air. This would be your speed in that direction, or your velocity, after the first second, and the second, and the third, the fourth, the fifth, the sixth. It's not ideal, basically. Fortunately for us, however, this speeding up process doesn't continue indefinitely, and that's because of a lovely thing called terminal velocity. When an object moves through the atmosphere, that object is literally slamming into particles of air. This is something you can feel if you move your hand around really fast, or if you stick it out of the window of a moving car. The air molecules can't get out of the way fast enough, so they build up, creating high pressure. And on the other side of the moving object, the molecules can't fill in fast enough, which creates a small vacuum, or low pressure. The difference in pressure is drag. Every falling object has a speed at which the force of drag equals the force of gravity on that object. And at the moment it reaches that speed, the object will stop accelerating and maintain a constant or terminal velocity. As you continue to fall through the air, you'd stop accelerating at about 54 meters per second, and so that's your terminal velocity. That's about 121 miles per hour. Before you hit the ground, though, it would be nice to increase your drag some more. That's what the parachute is for. After it opens, you begin to decelerate, and your velocity decreases until your velocity equals the new force of the drag. This is your new terminal velocity, about 5 meters per second, or about 12 miles per hour, if you want a safe landing.
Out a window out of an airplane either, so nope, no jumping out of planes for me. But terminal velocity is basically you stop accelerating towards the ground. Your air resistance equals the downward force. So like when you have a parachute, the force of air resistance is equal to the force of gravity. No acceleration, the forces are balanced. You continue to fall towards the ground, but you're not accelerating anymore.